Hello everyone, I am Anu Lohachab, currently pursuing MTech in Computer Engineering from NIT Kurukshetra. This video is about the project assigned to us as a part of Big Data and Analytics Lab. Our project is about building a chatbot application. The problem statement of our project is to build a chatbot system using natural language processing techniques. Before moving on to the implementation part, let's first go through the basics required to understand the implementation of project. Let's start with basic understanding of what chatbot is. So basically, a chatbot is a computer program designed to simulate conversation with human users, especially over the internet. Some of the ways in which companies are using chatbots are maybe to deliver a flight information or as a customer support or any other way according to the requirement. So broadly, there are two variants of chatbots. One is rule-based and another one is self-learning. In rule-based approach, a bot answers question based on some rules on which it is trained, whereas in the self-learning bots, some machine learning based approach are used and they are more efficient than rule-based bots. These bots can be further of two types, retrieval based and generative. In the retrieval based model, a chatbot uses some heuristic to select a response from a library of predefined responses. Heuristics for selecting a response can be engineered in many different ways, from rule based if else conditional logic to machine learning classifiers. Whereas in the generative boards, they can generate the answers and this make them more intelligent as they take word by word from the query and generates the answer. Basically, what we are going to implement is a self-learning retrieval based chatbot. So now understand some basic terms before moving on further. First, let's talk about what is NLP, an abbreviation for natural language processing. NLP is a field of study that focuses on interaction between human language and computers, or we can say it is a way for computers to analyze, understand, and derive meaning from human language in a smart and useful way. Whereas NLTK or Natural Language Toolkit is a popular open source Python library for natural language processing. It provides tools and resources for tasks such as tokenization, stemming, tagging, parsing, and machine learning based sentiment analysis. So first step in implementation of building a chatbot is to pre-process the text. First step is to convert the entire text into uppercase or lowercase. This is done to treat the same words in different cases as same. Uh, the next is tokenization. So tokenization is the term we use to describe the process of converting the normal text strings into a list of tokens. The next is stemming. So stemming is the process of reducing inflected words to their stem, or we can say to the root form. For example, if we have to stem the words stems, stemming, stemmed and stemmatization, the result would be a single word, that is stem. Whereas lemmatization is a slight variant of stemming. The major difference between these is that stemming can create non-existent words, whereas lemmas are the actual words. Examples of lemmatization are, that is, run is a base form for words like running or ran. Now let's understand what exactly bag of words is. So after we are done with initial pre-processing phase, we need to transform the text into a meaningful vector of numbers. So the bag of words is the representation of text that describes the occurrence of words within a document. It mainly involves two things, that is a vocabulary of known words and a measure of the presence of known words. For example, in our dictionary, if our dictionary contains the words learning, is, the, not, great. And if we want to vectorize the text learning is great, then we would have the following vector 1 1 0 0 1. That is, 1 is set for learning is great and 0 for the and not. But the problem with the bag of words approach is that the highly frequent words start to dominate in the document. So we have to rescale the frequency of words. So one approach to rescale the frequency of words is TF-IDF, where TF stands for term frequency and IDF stands for inverse document frequency. So the term frequency is simply the number of times the word appears in the document, whereas the inverse document frequency is a measure of how rare or common that word is across all the documents in a corpus. The TF-IDF score of a word in a document is the product of its term frequency and inverse document frequency. The higher the TF-IDF score is, the more important the word is in that document. So moving on to the implementation part. First, we have imported all the necessary libraries. Now for the corpus purpose, we are using Wikipedia page for chatbots. We have just copied the contents from that page and placed them in a text file named as sample.txt. Next, we have converted the entire corpus into a list of sentences and a list of words for further pre-processing. Next, we have defined the function lem tokens, which will take as input the tokens and return the normalized tokens. Next, we have defined a function for a greeting by the bot. That is, if the user's input is a greeting, the bot shall return a greeting response. Next, to generate a response from our bot for input questions, the concept of document similarity is used. For that, we have imported the necessary modules, that is TF-IDF vectorizer and cosine similarity, where TF-IDF vectorizer is used to convert a collection of raw documents to a matrix of TF-IDF features, whereas cosine similarity is used to find the similarity between words entered by the user and the words in the corpus. So we have defined a function that search the user utterance for one or more general keywords and return one of the several possible outcomes. And if it does not find the input matching any of the keywords, it returns a response, I'm sorry, I don't understand you. This is the code we have used for our image. Finally, we fed the lines that we want our bot to say while starting and ending a conversation, depending upon the user's input. Now let's see how it works. For example, if I start with a greeting input, okay, it returns one of the greeting response. After that, let's try to interact with it. Yeah. So that's pretty much about it. Thank you.